All right, let's go ahead and get started. I do want to welcome you to this worksheet. This is reading solubility curves, and we will not need a calculator for this one, so we're going to go ahead and get started. Let's talk a little bit about what we mean by a solubility curve. Well, essentially what we mean is the relationship between temperature and solubility. In this case, the solubility is in water. In fact, it's solubility in grams per 100 grams of water. So for any given temperature, I can look at one of these solutes, and there are 6 listed. Potassium nitrate, this is the curve for sodium nitrate. This is potassium bromide, ammonium chloride, sodium chloride, and yttrium sulfate. So these are the solubility curves for 6 different solutes dissolved in water at various temperatures. So let's take a look at one particular one. Let's take a look at this one right here to start with, and we're going to be asked about that in just a second anyway. So what do we mean by solubility curve? Well, what I can see is that if I focus just on potassium bromide, I'm going to make a red line just across, just like that, to kind of highlight it. If I look just at potassium bromide, what I can see is as the temperature increases, as the temperature goes higher and higher and higher, going from left to right, it is moving up incrementally in 10 °C increments. The solubility is getting greater and greater and greater, gradually, but it is happening. So I can see immediately that potassium bromide has, and most of the other solutes, by the way, are increasing in solubility as they increase the temperature. So let's take a look at a question. Let's take a look at number 1. It says, how many grams of potassium bromide can be dissolved in 100 grams of 40-degree water? So I'm interested in a couple of things here. First of all, the water is at 40 degrees. That's important. And I'm looking at potassium bromide. So again, let's go back to that curve. We want to look at 40 degrees on the temperature scale here on the x-axis. So at 40 degrees, if I follow the curve, or if I follow up, I can see that it's not quite, if I look horizontally at the 80, it's just shy of the 80. I'm going to estimate it to be, 78 grams. In other words, at 40 degrees, if the water is at 40 degrees, I can dissolve a maximum of 78 grams of potassium bromide, but no more. Anything more is going to result in some of the potassium bromide falling out of the solution. It'll just form a puddle on the bottom of the water of potassium bromide, right? A solid kind of a mass at the very bottom of the container. So I can dissolve a maximum of 78 grams, but no more. So we say that the solubility then of potassium bromide in water at 40 degrees is 78 grams, and we're done with the first one. Let's look at number 2. What mass of potassium nitrate can be dissolved in 200 grams at 30 degrees? So 30-degree water, this is potassium nitrate, but look what's changed here. 200 grams. Well, here's the strategy that I'm going to use. I'm going to look up potassium nitrate at 30 degrees, and I'm going to find out from the graph how much 100 grams can hold, and then I'm going to double that. So let's take a look at the graph. If you look at potassium nitrate, this one here is potassium nitrate, and I follow that graph down, we're looking at 30 degrees here, and I follow that graph down at 30 degrees, that's going to be right around there. So what I'm going to do is look across and see that, well, if this is 20 and this is 40, that 30 is right in the middle. I'm going to estimate that to be, roughly 36. So if I follow that down at 30 degrees, I'm going to say it's right here. I'm going to say that's about 36. Remember, I have to double it because I'm being asked about 200 grams of water. So I say 2 times 36, or about 72 grams of potassium nitrate, is the maximum that can be dissolved in 200 grams of water at 30 degrees. And I'm done with number 2. Let's look at number 3. Which compound solubility seems to be least affected by temperature? Well, when I just survey all of the solutes, I can see potassium nitrate, sodium nitrate, potassium bromide, and ammonium chloride, they all increase in solubility as the temperature increases. As I look at the x-axis, I can see as temperature increases, those increase. Yttrium sulfate, on the other hand, decreases in solubility. It's the one exception to the rule. But let's look at sodium chloride. As you look across, this is sodium chloride here. If you look across, that particular graph is pretty even, pretty horizontal. That means it doesn't really matter what the temperature is. The solubility of sodium chloride in water is going to remain essentially the same regardless of the temperature. So the answer to that question is sodium chloride. We're done with number 3. Let's look at number 4. It says a solution contains 20 grams of yttrium sulfate in 100 grams of water at 35 degrees Celsius this time. They're asking me, is the solution unsaturated, saturated, or supersaturated? And we want to justify that answer. So what do we mean by unsaturated? Well, what we mean is that the solution is holding less than the maximum amount of solute that can be held at a given temperature. So that's what unsaturated means. Saturated means we're right at the limit, that you cannot hold any more. You can hold that amount of solute completely dissolved in the solvent, but no more. And supersaturated is a special situation that I'll describe a little bit later. But for now, we'll just hold off until that one comes up, and then we want to justify the answer. So let's take a look at yttrium sulfate at 35 degrees. So if we look at the graph, if this is 35 degrees, when we look at yttrium sulfate, that's this one right here, we go up. That looks like it's about, well, let's say it's right there. So if we look horizontally, if we go across right here, that puts us at, well, right at 20. Well, it's telling us in the problem that, in this particular problem, that there are 20 grams. That means we're right at 20 grams, which is the saturation limit, the maximum that can be held of solute, maximum number of grams of solute that can be held by that number of grams, or by 100 grams of water. So we say that the solution then is saturated. It's not unsaturated. It doesn't have less than. If it had 10 or 15 or even 19, it would be unsaturated. But at 20 grams, it's completely saturated. That's what the graph tells us is the maximum that can be held. By the way, if it held 22 or 23, we would call that supersaturated, but that's just not the case. So that's number 4 rather. Let's take a look at number 5. Number 5 says a solution contains 20 grams of sodium chloride and 100 grams of water at 40 degrees Celsius. How much more sodium chloride could be added? So we're going to look at sodium chloride, right, at 40 degrees Celsius and see what it can potentially hold. Well, remember that sodium chloride was this one right here, and it really isn't temperature dependent. So it doesn't matter if it's 35 degrees or anything else. I'm just estimating, if this is 20 and this is 40 and this is right in the middle, it's 30. This is a pretty wild estimation, but I'm going to say it's 35 grams. So I'm going to say that at that point right there, it's 35 grams is the maximum amount of sodium chloride that can be held. Well, they're telling me that it's currently holding how much, it's telling me that it's currently holding 20 grams, right? It's saying that you have 20 grams of sodium chloride and 100 grams of water. Well, if it can hold maximally 35 grams, but it's currently holding 20 grams, that means I can add an additional 35 minus 20, 15 grams more could be dissolved. That's my answer. 15 more grams could be dissolved. That's number 5. Number 6 says this. At what temperature are the solubilities of potassium bromide and potassium nitrate the same? So we're going to look for potassium bromide and potassium nitrate, and we're going to look to see where they intersect, right? So if we look for potassium nitrate, it's right there. Potassium bromide is right there. The intersection is right there, you see? Right there. So if that's the case, if I look down, the temperature at which they intersect is 55 degrees Celsius, right? So my answer would be then about 55 degrees Celsius is the temperature at which the solubilities are the same. Let's look at number 7. It says, in general, as the temperature of the solvent increases, the mass of a solid solute in it will increase. Which of the compounds in the graph is an exception to that rule? We've already made reference to that. It's this one right here. It's yttrium sulfate. This one down here on the bottom. Notice that as the temperature increases in 10 degrees increments, the solubility is decreasing. The solubility decreases, and so it's an exception to the rule. For the most part, when a solid is dissolved in the liquid, there are a few exceptions, and yttrium sulfate is one of them. But for the most part, you can see that for potassium nitrate, sodium nitrate, potassium bromide, ammonium chloride, as the temperature increases, solubility also increases. So the exception to the rule would be yttrium sulfate, and that's our answer for this problem. Okay? Let's take a look at the next one. Number 8, how does the solubility graph of gases dissolved in water compare to the curves in this graph? Well, we don't really have to look at the graph for this one, but I need to tell you that it is exactly the opposite. So we've just learned from this graph that as the temperature increases, a solid increases its solubility in a liquid. But the exact opposite is true of gases. As the temperature of the solvent increases for gases dissolved in liquids, the solubility decreases. Think of, for example, a bottle of, or a can of Coca-Cola. If you put a can of Coca-Cola on a hot sidewalk on a hot summer day, it's going to go flat very, very quickly. The reason is because that liquid cannot hold very much gas. It will very quickly become flat. But if you put that Coca-Cola, even opened in a refrigerator, because of the temperature, it's going to be able to hold that gas and dissolve more gas per unit volume of liquid. So again, on number 8, we're going to say that it's exactly the opposite, as we would see liquid or solid dissolved in liquid. As you increase the temperature, the solubility increases. But for a gas dissolved in a liquid, as you increase the temperature, the solubility decreases. We're done with number 8. Let's look at number 9. Number 9 says a solution of potassium nitrate contains 130 grams in 100 grams of 70-degree water. Is the solution unsaturated, saturated, or supersaturated? How must it have been prepared? Well, let's take a look, first of all, at the potassium nitrate situation at 70 degrees. So at 70 degrees, what we can see is that for potassium nitrate, it can hold a maximum of, here's potassium nitrate at 70 degrees, it can hold a maximum of, we're talking about right here, if I look across, 120 grams per 100 grams of water, right? Maximally. That's at least theoretically how much it should hold. But they're telling me it's holding not 120 grams, but more than 130 grams. How does that happen? Well, it happens because of the fact that the solution is what we call supersaturated, right? What that means is the solution was heated to above 70 degrees Celsius, an additional amount was added, and then it was cooled down slowly, right? That's the key. If you take a solution that's very hot or very warm at least, and you put in a lot of the solute, right? It can dissolve that amount of solute because it's hot, and then you cool it down slowly and without touching it and carefully, and not even allow one piece of dust to fall on it, because that will cause a lot of solute to fall out of the solvent, to fall out of solution. If you can do that, you can form what's called a supersaturated solution. So this situation is one of supersaturation. So usually only about 120 grams of potassium nitrate can be dissolved in 100 grams of water at 75 degrees. We saw that since this solution contains more than this, it is supersaturated. It must have been dissolved in the water when it was warmer and then cooled down slowly. Folks, that'll do it for this worksheet. I'll see you in the next one. Thanks. Bye-bye.